other remote sensing activities in agriculture, right? In this particular context. So first thing what I want to talk to you about is plan with respect to irrigation, right? So typically we have done this project for several other different parts of India itself, right? Where what we do is once you fly a drone, you will basically get using a normal camera itself, right? You will basically get a three-dimensional map of the region, right? Using that, we typically do a hydrology analysis and a watershed analysis. So using watershed analysis and hydrology analysis, you can actually see where the water is exactly logging, right? Which is the most ideal place for farming. This is for in case of you want to map an entire village, or you want to talk about entire district of sorts, right? We can possibly give you a hydrological map with respect to the current rainfall and with respect to also the undulations of the land, right? So this is very interesting what you can possibly do here. So this can help in irrigation planning. Typically this also is used in other contexts with respect to when you have a large solar park or a solar farm. Also people use it, or a construction site, they typically use to figure out how to create canals and so many other things for general water movement direction, right, and leveling. So that's something which we can do, right? The other important thing what we can do is basically basis seed spacing, right? So what happens is the fact that when you typically have you know crops such as this, right? When you have other planting other trees in the region and so on and so forth, typically what happens is you have shadow related problems in agriculture, right? Or where there's a shadow of a particular tree or something which can affect where you're supposed to plant a particular seed or crop, right? In this particular case, again, once you fly a drone, you can either use a lidar drone, or you can use a lidar camera sensor, or you can use a normal camera also, where you can actually assess what is the seed to seed spacing, or where the rows of the plants are supposed to be put for much better yield per se, right? So that's another very interesting use case. One of the things that we also did earlier was about weed identification, right? This is usually using an NDVI camera, right? When you put an NDVI camera on a drone and you fly around a particular cropping pad, a particular farm, you can automatically identify very clearly, easily, some indicators with respect to um, where the weeds are located, or also the health of the plants and crops, right? Other than NDVI, you can also use other sensors like hyperspectral cameras, right, and multispectral cameras to identify some of these weeds, right, and damages which are present in a particular land, right? The reason why drones are being used in this case, previously people used to use satellites for doing a gross estimation across different districts, but because we have drones which can fly much closer to the land, you can automatically easily pick up lot more clarity from a plant to plant standpoint, and also from a distance between plant standpoint, right? So that's another very interesting thing that you can use using NDVI, and you can use using hyperspectral multispectral cameras, right? So again, using the very similar thing, you can also detect plant stress, which is basically where you can pick up the chlorophyll content, and you can say, okay, you know what, this plant is not really performing well, and you can do this on a plant to plant basis rather than doing on a farm to farm basis, right? So that's another very interesting thing where you can do with respect to plant stress, right? Things around soil quality is also what you can get using drone data, right? You There are multiple case studies with respect to NDVI and other mostly multispectral cameras, where you can actually detect and see what is the exact amount of quality of the soil that we are currently having for the for irrigation or for growing plants, right, which can actually help in giving the best crop mix also, right. So that is something which you can also do using these kind of cameras, ndvi cameras, as well as multispectral cameras, right, and running an analysis over there. Well, this or what I told so far is mostly around detection, right? But one of the things which can easily you can do tomorrow using just a simple camera is about crop counting and plant counting, right. So what is interesting here is, if an early stage plants, as you can notice over here, these are all early stage corn plants, right, and you can see a red dot on top of this. That is the detection. This is basically detecting whether the plant is there or not, right. So essentially, usually what happens is the fact that when we all in agriculture, when we go place seeds in different in whatever manner, right, in corn they usually use 7 centimeters between two seeds, but any other other plant to plant seed, this thing challenge is some over the course of say 120 days or a particular cycle, so many plants, some seeds might not germinate, some seeds might some plants might die over different reasons, right. So we typically don't get the most accurate yield after say planting 30,000 or 40,000 seeds. We do in a particular acre of land, we do not know how many plants are currently there at any given point in time, right. We typically, in our experience when we used to work with Syngenta, is basically we used to have a gross estimate. We used to say, this 1 acre of land can be 35,000 plants, some areas can be 25,000, right. So we don't exactly know what is the exact plant count of every particular farm in a given region, right. So given time, right. So one thing that we did was, when you fly a drone, you can actually pick up individual plants, right, as you can see here. Hopefully it's clear to you. And we can have an algorithm to detect that plant and count that plant as well, and call and have a unique plant id, right. So what happens is, you can now count accurately in 1 acre of land that there are 35,000 plants or 35,342 plants and so on and so forth, right, rather than having an estimate of saying, okay, there can be 30,000 plants or 32,000 plants, right. And this is very useful for all high value plants. Can be corn, can be chilies, can be any other plant which you can easily discern from the aerial point of view, right. Can be done for trees as well, can be done for so many other plant species, right, where you want to know what is the most accurate count of your plants in a particular farm of we can easily do that. And this so we have done built a system in a way that once you fly a drone, that the same day or the less than the same, like literally after flying a drone within an hour or 2 hours, you'll know what the count of the plant is, count of your plants in a particular farm is, right. The other option is basically manually counting each of these plants, right, to get the accuracy. So that is a very interesting use case on plant count. So this can be used for yield estimation, typically using drones, right. The next, I think, what you everybody would be already aware of is basically spraying, right, where you have when you have a large this thing, you can actually detect where you have weeds and where you have so many other parts after doing ndvi mapping, and then come next time and go do spraying in that particular region only, rather than spraying in the entire 1 acre of land. Just spraying in regions which are needed and necessary is another very useful use case, right. In all of these are in terms of management, right. Same thing we can use for irrigation as well. So in some cases, what you want to do is the fact that if you have a thermal camera on the drone, right, you can also detect moisture content, right, of the entire farm, and say, okay, in these regions of the farm is where you have less water, right, and less moisture, right? And these regions of the farm where you have more moisture, right? You can, if you just put in a thermal camera, you can easily detect, say where you have actually there's water and where there is, inadequate water, right? And you can also spray, you can also water the plants accordingly, right? Of course, in India this might not be so relevant, but in several parts of the world this is a very useful use case, especially when you want to drip irrigation and some, and it's completely automated, and so on and so forth, right? Last thing what I want to talk about is, for typically for seed companies, they are looking for, simple, GIS mapping of their entire farmlands. Suppose you have 2000 acres of crops and plants across, say, a few districts, and you want to know, I have a visual reference for, and how many acres of your, and you're managing, say 100 farmers today, right? And you want to know any point in time, you want to know real time, how many plants are there, what is the area of the planting, etc., etc., what is the isolation distance between, each your part, your land, and the other land, which is from, who's using some other competitor seeds per se. You can automatically do that using a GIS platform, and you can do a farm land management, right? So for example, here we know exactly there's around 1000, around this much square area, square meters, 1028 square meters, right? And this is the isolation distance, which basically means between this particular, your land where your corn using your seeds are growing, versus some other person's land, and some other competitor's seeds which are growing over there, so that if this distance is very low, right, which means there can be cross pollination, and it can affect your seed quality or your seed, for your agricultural purposes, right? So you can easily detect what are the distances between, which are between your plots of land if needed, right? And you can have a central GIS database, right, on a farm level, which is also possible using drones per se, on a farm, just on land management, right? And you can associate, okay, this farmer has this many plants under his management, and so on, right? So that is something which is again very useful. The last, part is basically when you basically have a problem, in case where, you have a natural disaster, right? And you need, and crop insurance is needed, right? And you want to assess the amount of damage which is there. We have done this for, the state of Karnataka, government of Karnataka, I think, during the Coorg floods, which happened in 5 years ago, 2018, when Coorg was flooded, and they wanted a real-time assessment of how much farm area is underwater, right? And instead of going actually over there physically and checking road, you can fly drones, and you can actually map out regions where water is over a particular land, right? And you can overlay revenue maps and say, okay, you know what, this particular kata or this particular land has actually is underwater and actually damaged to either 25%, 50%, or fully damaged, 100% damage, right? So that is something which you can do, using natural, for a natural disaster, in case of a natural disaster, right? So that's, of course, this is been done across the world, multiple places, and in India also we had done it for government of Karnataka 6 years ago, right? And also government of Andhra Pradesh some time ago, right? So this is another important use case for insurance purposes, and this is the most truest form of insurance, for actually, getting insurance from your farmland. And this again doesn't require too much, payload. You can use a normal camera and get this amount of insight, right? With respect to assessment, and again you have same context with respect to crop insurance, right? uh, can be used again for different regions other than just crop insurance, can be used for any asset insurance. In fact, now a lot of companies have started using, drone based assessment of farmlands, right? So that's basically what I had for you today, right? I didn't want to take too much time, but would love to, answer any questions if anybody has it, or you can see me tomorrow. You can also, where I'll be demonstrating our product, software product also, so that you can also get a real time, view of our software, and things like that as part of the next session, right? But would love to answer any questions you have on this particular topics of payload and agriculture, in terms of agriculture or any other industry. Also would be very happy to answer questions. Thank you.
Thank you very much, Nilanji. There are 3 questions. Is it necessary for the plant stage to be set for yield estimation? Like
there is, it depends, right? So what we've done is basically for yield estimation, the earlier it depends on plant to plant, right? So for example, in case of chilies, right, what we have is you don't need to fly at all. You can fly at any point in time because chilies are separated in nature, right?
Okay.
But corn, basically, after 30 days of corn starts growing over each other, right? So it's very hard to identify individual corn from the top view. So what is needed is you have to fly for corn in 5 days or 10 days time, get one map, and then keep flying the using that base map, keep continuously flying, right? So that you can continuously keep assessing what is the population after that, right? So that is a way to do it, to avoid the plant stage thing. But if you're flying for corn after 60 days, then it's almost very difficult to know the plant population at 60 days for the first time.
Okay.
Yeah.
So any other hack for performing this type of yield estimation analysis?
Any other, sorry?
Any other shortcut method or hacks for this type of yield estimation analysis?
uh, there are, typically today we do a big shortcut, right?
Okay.
Without drones, we basically we count a row, we count 10 rows are there, 20 columns are there, 10 into 20 is 200, right? That's how yield estimate currently happens. Using drones, you can do it in a much more faster and more accurate manner, right? By flying a drone and counting the actual plants.
Okay, fine. Thank you. Can you please throw some light more on central GIS database? This is a question from Tejasvi Banda. I think in tomorrow session you will be covering that, right?
Yes.
About analysis and how to work on it.
Yes.
So in the tomorrow session you will be able to find the answer for this question. Any other question related to this session? During the crop fire situation, what type of sensor is favorable?
During the crop, what, sir?
What type of sensor is favorable
for crop identification?
Crop fire situation, crop identification or fire identification? I just want to make sure from the participant. I will unmute you. Please, you speak to sir. Yeah, can you speak now? Yes, Tejeshwari.
Sir, I just want to know if there is some crop fire. I mean, if at all we are flying for a bigger area, like 100 acres, and yeah, of course, the drone will be in the vicinity area. But if we wanted to estimate the crop that has been under fire, like that is one of the disaster for agriculture fields. If we wanted to know the crop fire and the spread analysis, so what we can do during the crop fire time?
See, during crop fire, actually depends on what you're doing, right? So if you want to identify a fire, you can even use a simple camera and see whether there's a fire, right? But if you want a map of the region, then you have to again use a camera and do mapping of the region, where you actually fly in a particular pattern and get a map of the region, and then you can identify the fire, how much it's spread, right?
Okay.
And the thing, and there are of course thermal cameras which are again there for, if you really want to know the temperature of the surrounding regions, right?
Okay.
So if you want to really get into temperature and see, okay, this other part also has so much high temperature, can I even walk there, or is there somebody stuck over there, right? In those cases, you can use a thermal camera, right?
Okay. Yes, sir.
which will also help you, identify fires even in the night or even in some other parts of the day where you can't see clearly, right? Because of
Yeah.
smoke, and because of the smoke in the region, you don't know which extent is that. Thermal cameras are typically useful.
Okay. Sir, one more thing. Like for soil moisture estimation, can we use SAR
You can,
sensor also?
you can, right? But SAR on drones have not yet come up. SAR is basically used only. So currently, they have satellite-based SAR, right? So essentially
Yes.
now, essentially drone-based SAR is not yet come, but it'll come. It'll definitely come in a year or two, or you too. They will definitely SAR also will come.
Sir, one more doubt on this. So, if we are doing some, suppose if we are doing some micro level plot analysis within the same area, within the same crop type plot only, we want to see the variations in different properties of the crop. So, in that particular case, for supposing for soil moisture only, if we are taking, how should the ground estimation to be taken across the field to see the accuracy?
No, you need to use ground control points for sure, right? For mapping, right? So
Yeah,
if you're
for
doing
like
yeah, go
for
on.
in the map only, how should the ground based sensors to be used? Either, how should it be defined? How should it be taken? How the sampling should be done in order to take the complete good accuracy?
Depends again, right? So you, if you want, yeah, depends on the resolution on what you want, the thing. So more ground sensors you have, the better, because anyway you're doing remote sensing. Using a
Yes.
drone, you're doing anyway remote sensing, right? So remote sensing will have a resolution by itself, right? So
Oh,
resolutions of the cameras will depend few centimeters, and based on the height of the drone which is flying, some few 4 5, at least you'll get resolutions of only 10 20 centimeters as you,
okay.
right? So
Sir,
anything
sir,
yeah.
one more little doubt. Sir, in case of especially like multi-cropping, is there any other different way to, segregate as apart from hyperspectral sensor? Is there any different way so that even at the, because to segregate between the plants and plants in the very early stage only? Because what will happens is in multi-layer cropping, initially only one type of crop is been put, and after some certain age, different crop is set. So it becomes a little difficult for us to estimate the yield also in that particular type. So is there any other way so that we can segregate it
I
comes, I mean,
got it. Point is, you have to do. So one of the things that we have done in these kind of cases, or what you're trying also, is the fact that you have to do machine learning, right? You have to do computer vision and detection,
yes,
right?
yeah,
So now
yes,
the computer vision and detection, you have different parameters, right? Height can be one of the
yes,
parameters. If you're flying today and you have height, you have different heights, right? During the
okay,
crop, you can have, of course, color parameters is one thing, but color parameters, if you're flying only RGB, you might not get so much color parameter variation, right?
yeah, yes, sir,
But you can also use height as a parameter, right? You can, if you fly lidar, or you have, if there is some amount, if you fly low enough, you can also use height as a parameter, right? Height of the plants,
yeah, okay,
right? So that
yes.
also can give you another dimension to, play with. But at the end of
But
the day, you have to computer vision
uh,
only.
yeah, so one more thing in multi-cropping patterns, because there are creepers also. That is like extremely it becomes difficult
Hmm.
again. Like sort of like some 9 to 7 types of cereals are mixed. Out of them, like some of the creeper sort of additional useful weeds that is generated.
Hmm.
So creepers, so we can't even do it right.
Correct. You
And
can't. It's going to be very hard. So the point is,
yeah,
the problem in all of these cases is, unless you try, you will
okay.
never know whether it is actually possible or not,
Okay, sir.
right? Because
Yes.
the challenge really becomes that, there is no, one. That's one of the things, right? You don't know the cropping, patterns, or the difference between the seed spacing. In some cases, you might have
Yeah.
overlap between two crops, right?
Okay.
So
Yes.
unless otherwise you actually try an algorithm and try doing some machine learning, and then you figure it out, and that's the one of the reasons why this is not yet fully productized world over. That is why there's no software for this already,
Oh, acha, okay.
right? Otherwise people have already built a yield estimation software,
Okay.
right?
Yes,
It
sir.
is
Yes,
not
correct.
there because it is changed. It varies so drastically in every other part of from farm to farm,
Yeah,
right? So yeah.
got it, sir.
Hmm.
Yeah, thank you so much, sir.
No
Thank you.
worries.
It's
Thank
very,
you, Tejas.
it's a very good idea that you're taking plant stage as one of the parameter. I mean, I really liked it. Thank you so much.
No worries.
Thank you.
Thank
Thank
you.
you. So, if any questions, we will take tomorrow after this session. Meanwhile, thank you very much, Mugilanji.
Thank you.
Now I request our CEO and Dr. Guti Bhaskar sir to have few words, if any.
Sure, it was really a very good session, very informative and insightful talk you gave. I'm sure all the participants they got a lot of take-home message from your talk. On behalf of KSTA and all the participants here, I thank you immensely, Dr. Gilan, for a wonderful talk. See you tomorrow. And I also thank Dr. Bhaskar, who has been with us since morning. Thank you, Doctor, and also Dr. Lingdal and all the participants. On behalf of KSTA, thank you very much. Please join at right time tomorrow. We'll have four more sessions tomorrow. With this, I request my colleague, Mr. Umesh, to take over. And if there are any questions, are there any questions, Umesh?
No, sir. No, sir. As of now, there are no questions. If there is any words from Dr. Guti Bhaskar sir, they can speak, sir.
Dr. Bhaskar.
Any comments, sir? Any feedbacks? Yes.
Yeah, how is it? So today I also participated in the sessions. I think all sessions are quite good and useful. And a lot of interaction also took place. That seems to be quite interesting. So I hope this is quite useful to all the participants. Thank you all. Thank you for joining. So we'll see you tomorrow morning. Thank you. Thank you.
Yes,
Many.
yes. Thank you, sir. Thank you. I request all of you to join tomorrow early because we have 4 sessions and the first session begins at 10 o'clock. Thank you. Thank you. See you tomorrow. Thank you, Karthik ji.